Hello. First of all, before we start talking about triangle similarity, which we shall, let us review what are the four main postulates to prove that two triangles are congruent. Here's a hint. These all have the three-letter names. What are they? ASA, AAS, SAS, SSS, angle and side, of course, angle, side, angle, 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 side, angle, side, and side, side, side. Looking at those, again, these prove that triangles are congruent. In order to have two triangles proven to be similar, we don't need as much information necessarily. We can be working with a little bit less. In particular, let's focus here on angle, side, angle. So when we've got two triangles, notice I've got one triangle here on the left. I've got triangle ABC. The measure of the angle B is 40 degrees, A is 70 degrees, A and the length of segment AB is 5. So let's make the triangle on the right that's similar. Notice that I've got the length of that segment is the same. If I make this the same measure, so if the measure of angle E is 40 degrees, and I can just keep that going. I'm just making a ray that goes off to infinity. And I make angle D such that it is 70 degrees. And I don't really care where that one goes off to. That's off to infinity as well. There's another ray. If I make those angles the same, then they have got to intersect at the same spot. That's what really makes these triangles congruent. The angle, side, angle. There's no other way that they can intersect right up there if they've got two angles that are going off from the same place. You can think of a number of analogies about this. You can think of golf. You can think of balls that are being thrown. You can think of I don't know. For me, for some reason, I always picture some old World War I map or something like that with machine gun nests overlapping. For some reason, that's the analogy that stuck with me. Probably because I had a really good modern European history course when I was in high school. But at the end of the day, if you are going from that point on the left with measure of angle 40 degrees, you've got the distance of 5 between them. This is where they must end up. And that proves congruence because the side is locked in. And they are a set distance apart. The other thing about this, before we move on here, is that the measure of all three sides, all internal angles of a triangle add up to 180 degrees. That's a fact. That's how it is. So if this is 40, that's 70, this angle has to be, well, 180 minus 40 plus 70, which would equal another 70 degrees. So this right there has got to be 70 degrees. This right there has got to be 70 degrees because that's the amount that would make all of the internal angles add up to 180. So this is why that angle side angle works. So let's look using that same thought process. We can prove that angle 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 is going to be a way to prove that two triangles are similar, not congruent, but similar. So this time I've got my same triangle, basically. ABC is on the left, but I've got DE. This time I've got a length of 10. So my ratio here from the triangle ABC on the left to triangle, what's going to be DEF on the right would be, let me put it in blue here so it stands out, 5 to 10, or 1 to 2. So same process. There's another 40-degree angle goes off. There's another 70-degree angle goes off. And if this is 40 and 70, this angle still is 70 degrees. That means this angle also has got to be 70 degrees. And I can look and I will be able to see that although the sides are not going to be congruent, they are going to hold on to the same ratios. You've basically got, for lack of a better term, kind of a mini triangle on the left, same angle measures, 40, 70, 70, and then its larger sibling here on the right, 40, 70, 70. You will have corresponding parts having the same ratio with each other. So angle, angle, angle is a way to prove that two triangles are similar. Two triangles with all three interior angles congruent will be similar to each other. And just to add on to that, you can say that corresponding angles are congruent and corresponding segments are not congruent, but they do have the same ratio to each other, or perhaps proportion might be a better way to say that. I think that sounds better. Which really goes back to the definition of similarity, that two figures, if they're similar, they will have the same angle measures, and they will have a proportionate sides to the corresponding parts. All right, bring in your questions, and have a great day.